Okay, so today we're on 11.3. This is the last section of chapter 11. And today we're going to be talking about normal distribution. And so when we talk about normal distribution, we're kind of talking about like this curve right here. If we were measuring shoe size on people, the whole world, what's a normal shoe size? And I'm not sure exactly what the normal shoe size is in the whole world, but I know that there are people with really big feet, and there are people with average-sized feet, and there are people with small feet. So let's say the big feet people were over here, and the small were over here. Okay? The average-sized people would be right here in the middle. And that would be a normal distribution. Most of us would be in the red. Some of us would reach out into the green, some of us to the blue, and then some of us still yet would be on the complete outskirts. What normal distribution is this. It's a curve that makes a normal. It's called a bell curve. This is the shape of a bell. Doesn't necessarily look like a bell, but it's supposed to be like a bell. Think like that. Ding dong, which is dead, right? The normal. This would be the normal curve, and the standard normal distribution would be this right here. Let's see if I can change colors because I think color's not blending real well. Pick a color that's not on there might be smart. Let's try purple. Right here would be +1. If this is 0 right here, this is 1. This is 2 standard deviations out. This is 3 standard deviations out. This would be -1. So -2, -3. Okay, and if you're within so many standard deviations, then you're in a, it'll tell you what percentage of people that you would be within. A z-score will tell us those numbers, the percentages, as you are 1.4 standard deviations out. How many people do you have bigger feet than? Okay, and we'll talk more about that as we go on. All right, so let's take a look at our curve here. If we know that 1, the standard normal curve, has 100% of all the people underneath it. Okay, that's the purpose. Within 1 standard deviation, 68% of the people lie. I'm gonna make this a little bigger. All right. Within 2 standard deviations, 95% of all the people are. And so you see this 34 plus 34, that's 68. So 68% of the people lie right here in the middle. Okay, just like it's over here. All right. If you go 1 more standard deviation out, you pick up, that's 95%. And if you go 1 more standard deviation out still, you get 99.7%. So you get almost everybody are within three standard deviations on any standard normal thing that you would measure. Shoe size, how much money people make, height, weight, all of that stuff. All right, let's take a look at this standard normal curve here. A normal distribution has a mean of x bar, so we call that the average, right there in the middle. So if you were right in the middle there, you would be perfectly average. This guy right here is perfectly average. Okay, the probability that a randomly selected x value lies between x bar. See, what they're asking for is the probability. That's what that P stands for, right there. The probability that x, whatever some number that I choose x, is in between x bar and x plus 3 standard deviations. It's all the stuff we have shaded right here. So all this stuff. What's the probability that you would be in here? And it's kind of like that whole geometric probability stuff we talked about. What's the area in that little spot right there? And so the probability that x lies between x bar and x bar plus 3 standard deviations, x bar plus 3 standard deviations, is shaded. So remember that graph we had on the last page showed us that first little area would be 34%. And the second area was 13.5. Now these are numbers you have to memorize for the test. So you have to have memorized that chart on the previous table. And the third area is 2.35%. And if I add all of those percentages up, I get 49.85% total. That's the percentage of the parts that are in between those two areas. Okay. Let's take a look at the checkpoint, see if you guys can come up with one here. Take a moment, pause it, and see how you do. All right, welcome back. You want to find the probability that x is less than, x bar minus 1 standard deviation. So let's take a look at that normal curve. Let's see if Mr. Emiot can draw it for us here. Okay. And so in that, this right here would be x bar. That's right in the middle. We know this. 50% of the population is here on the left side. And 50% of the population is here on the right side. Okay? What we have is 50% of the population, but it starts right here. Here and over is what I want. So what I missed out on was this 34%. So I'm going to do 50 minus 34. I'm going to get a 16%. That's the probability that that's going to happen. Now, generally, we report those probabilities not in percentages, but in decimals. So instead of 16%, we're going to call it 0.16. All right? Let's interpret this. Now, I found this little joke I thought was good. Take a moment to read that. Take a look at that picture. SAT test. He's a test administrator. So the dog, yes, he sat. No, he didn't. So that guy gets to pass the SAT. That's pretty funny. All right. So math scores. The math scores of the 2004 SAT exam were normally distributed with a mean of 518. That means if you scored 518, you are an average student who took that test. And a standard deviation of 114. That means if you scored 114 higher, you're one standard deviation out. So 68% of the people scored between 404 and 632, if I think about it that way. What percent of the test takers on the SAT have scores between 518 and 746? Well, there's 34 in that first slot there, right? And there's 13.5 in the next. And so the scores represent 2 standard deviations to the right of the mean. And we're going to add 34% plus 13.5%. And we're going to get 47.5%. All right. About what percentage of the test takers were less than 404? Well, 404 is right here. So that was one standard deviation away. There's 2 ways to do it. The score is 1 standard deviation to the left of the mean. And so you could add up 13.5 plus 2.35 plus 0.15 and get 16. Or you could just say if 50% of the people were to the left of the mean and I get rid of 34% of them because I just want these people right in here, okay, then that would equal 16% also. So that's 2 ways to think about it. All right, let's take a look at this stuff here. We're talking about height here. I found this great picture of these 2 women, one tall, one short. A survey of a group of women found that height of the women is normally distributed with a mean height of 64.5. So let's just think about that as a graph real quick. Bell curve, right in the middle, 64.5. You are right in the middle. That means you are 5 foot 4.5. If you are 5, 4.5, you are an average height woman. And with a standard deviation of 2.5 inches. Well, that means if I add a little bit to that, make that a little bigger, my bell curve there, if I can. If I add a little bit to it, if I add 2.5 to it, I get 67 inches. It means if you're 5'7", you know, you're obviously a little taller, and you're 1 standard deviation above normal. If you're 69.5 inches, you're 2 standard deviations. That means that you are taller than, think about it, there's 50% of the population over here, and there's another 34% right here in this little section, and there's 13.5. You are taller right now than 84, 94, 97.5% of all the people. That's pretty tall, right? And then if you're over here, another 2.5 percentage points, another 2.5 up, that would be 72 inches. So if you're a 6 foot tall woman, then you're taller than 99.7% of the population. So 6 foot and above, that's the rest of the equation. On the short side over here, if you're 62 inches, 5 foot 2, or 59.5, or 57. Okay, so there's the height of those women, right? Now, what we're going to talk about is Z-score. Now, you really need to know how to find a Z-score. Z-score is going to be important to you. This is if, you know, what if I'm not exactly 5'7"? What if I'm 5'5"? What percentage of the population am I taller than now? Or what if I'm 5'8.25"? So these are right on the standard deviations. The Z-score gets you the stuff in between. All right. So here's what you do. We're going to find the probability that a woman is at most 58 inches tall. So this is somebody who's right about here, 58 inches tall. Okay. What's the probability that she, basically, I chose a random woman and she's this tall or shorter? All the stuff in here. Okay, what's the chances of that? Looks small, right? It should be a small number I'm getting here. So we have 58 minus X bar. X bar is 64.5 divided by sigma. Now sigma is our standard deviation, which is 2.5. 2.5. So if I do 58 minus 64.5, I get negative 6.5 divided by 2.5. Negative 6.5 divided by 2.5 ends up being negative 2.6. Negative 2.6. Now I look on my table to actually find out what that percentage is. Now we have a table down here that your book set up for you, your notebook set up for you, and it looks like 0.0047 or 0.47%. Now the table that's in your book is going to look different. I want to show you that real quick. So let me drag that over here. Okay, let's see if I can drag that. Alright, looks like I'm not going to be able to make that picture any bigger, and that's okay. So I'm looking at that negative 2 right there, all the way over here at 2.6. And if you looked at that in your book, you'd find it was the same spot, 0.0047. But I just wanted to show you what the table in your book was going to look like so that you would have an idea. Alright, I guess I was able to get it bigger, but it didn't matter. Okay, now we're going to use the Z table to find that. So what's the probability that X is less than 58? Well, it's the probability that Z is less than negative 2.6. And I looked on the table and it showed that the probability less than 2.6 was 0.0047. So the probability that the woman is less than 40 inches tall is about 0.0047 or 0.47%. So if you picked a woman at random, the chances that that woman would be less than 50 inches tall is not very good. You know, generally she's going to be in the big bulk of all this area over here. You know, 95% of the women are going to be right in there. So you guys take example in, go ahead and take a look at that checkpoint and do a couple of those problems. So pause, work on checkpoint 2 and 3 and see if you can come up with the right answer. All right. So in example 2, what percentage of the test takers, so you got to look back at that table on example 2, and which percentage of the test takers were between 404 and 632? And I hope you saw that you had the middle, you had 404 was one over here, 632 was one over here. That's all these people right here in the middle. And that was 68% of the population. It was between one standard deviation to the left or to the right. Find the probability that a woman is at most 70 inches tall. So at most. So this is all the stuff less than on that thing. Now remember what we said about 70. Let's take a look at that again. Look where 70 was. 70 was way over here. Okay, so this is a big woman. 70 inches tall is almost 6 feet tall. So 70 is like right in here. So my z-score is probably going to be a little over 2 somewhere. All right, so let's take a look. We have 70 minus my average. Now my average height for these women, don't forget the average, my average height for the women was 64.5 and divided by 2.5. If I take 64.5 and divided by 2.5, or 70 minus 64.5 divided by 2.5, I end up with 2.2, and that's a positive number, 2.2. So let's see if I have better luck with my table here this time. Maybe I won't have better luck with my table. There we go. 2.2 on my table is, here's 2 right here, and 0.2 is right here, so it looks like I'm right there at 0.9861. All right, so my answer is 0.9861, or 98.61%. That means if I'm out looking for a woman and I find one, what's the chances that she's going to be less than 70 inches tall? Pretty good. What's the chance she's going to be more than 70 inches tall? That's the other question. Well, pretty low. 1 minus 0.9861 is going to give me the more than. All right, good luck. Thank you, guys.